morning, students. So we will continue our discussion of prefix and postfix expression. Okay. So today we will understand how to evaluate the given prefix and postfix operation using a stack. Since this is all about stack applications we are discussing. So how to use these prefix and postfix evaluation using stack? How to evaluate these expressions? Okay, so given this is a postfix operation, isn't it? This is postfix. How to evaluate it? What is the result of it using stack? We will see. So taking the first operation, let's see how it works. So first of all, remember when it's a postfix, we always evaluate from left to right. The evaluation is from left to right. Okay. So first of all, we have to take a stack. An evaluation starts from, as I said, left to right. First we will traverse and put the operands or push the operands into the stack. So what we have to do? We have to evaluate from left to right, and whenever we come across an operand, we have to push it into the stack. Okay. So first of all, we come across operand 2. So we push it into the stack. Then we come across 3. We push it into the stack. Then the next operand we come across is 4. We push it into the stack. Now what we get? We get an operator. Now star we get. So whenever we come across an operator, what we have to do is we have to pop the operands depending on the type of operator. If the operator is a binary operator, that if the operator requires 2 operands for its operation, then we pop 2 operands. If it's a unary operator, then it requires only 1 operand for its operation. So we pop 1 operand. So depending on the operator that we encounter, we have to perform the operation as per the number of operands, and we take it out from the stack and operate it. So since it's a star, it's a binary operand, we have to pop 2 operands. What are the operands? 3, 4. So 3 star 4 is what? 3 into 4, 12. 4 3 are 12. So we pop these and we push it again. So after operating, we push 12 back to the stack. So what is the content of stack now? 12, 12. Okay. Now after star, then again we move forward, we get plus. So whenever we get an operand, what we have to do? We have to pop. Whenever we encounter operator, we always, what we do? We pop operand. So what are the operands we pop now? 2 plus 12. 2 plus 12 is 14. Now 14 is again pushed back to the stack. What is the content of stack now? 14. Okay. Now this is completed. There is no further symbols left. So the answer of this is the evaluation. The result is, excuse me. So the result of the first prefix postfix expression is 14. Okay. Similarly, we will see how to evaluate the next postfix operation. Okay. So we will see the number 2. How to evaluate number 2. So first of all, we come across, we traverse from left to right. What did we find? 10. Since it's an operand, we push it. Then 5. We push it. Now we come across the operator plus. What we have to do? We have to pop these operands, and 5 plus 10 is equal to 15, and 15 is pushed back. So what is the content of stack? 15. After 15, that is after plus, we come around 60. So 60 is pushed. Then we come around 6. 6 is pushed. Then again our operator. Okay. So when we get an operator, what we do? We pop. So 60 divided by 6 is equal to what? Again 6. Sorry, 10. 60 divided by 6 is 10. So 10 is pushed. So what is the content of stack now? 10 is pushed, 15 and 10. Now division is done. Then we come across star. So what happens now? 10 star 15 is 150. 150 is pushed. 150 is pushed into stack. Okay. After star, what we get? 8. 8 is pushed into stack. And after that, minus. This is the last. Now, minus, what we do? We pop evaluate. It is 8 minus 150. So, what is the answer here? What is the answer here? Minus 142. Minus 142. Sorry, 150 minus 80. Yes, plus 150. So, 8 and 150 is there. Okay, 150 is pushed, after that 8 comes. So 150 minus 8 is 142. So 142 is again pushed back into stack. So final answer is what? 142. 142 is the answer. Okay. This is 10 plus 1. Okay, this is how we evaluate. 15 into 10. Whenever we pop operands, the first operand stays in the right side, the next operand stays in the left side. Okay? So remember this, whenever there is x, y and we come across a operator, binary operator, then how we evaluate it? We bring x here and we bring y here. So y star x. This is how you should evaluate in case of postfix operation. Okay? This is how we evaluate in case of postfix operation. Remember this is very important. Otherwise, you may turn up like what I did, minus 142. The answer is not minus 142, this is 142. Because this will move towards right, the inner one will move towards left, and the operator stays in between. This is how we perform the operation. Okay? I hope it is clear now. This is how it works. So this is 142. Now let's see how to evaluate a prefix, expression. Okay. Till now we saw how to evaluate a postfix, expression. Now we will see about a prefix operation. So given a prefix operation, how to evaluate this? So we will evaluate 3. So whenever in case of prefix operation, we always the evaluation starts from right to left. We evaluate from right to left. Okay, and the procedure is same. It's just that the evaluation is done in prefix operation. Prefix. What happens is if it is x, y, and whenever you come across operator, place the operator in the left side of the stack. Suppose star. Then how the evaluation is done? X comes here, y comes here. Okay, x star y. This is how the evaluation is done. Okay, got it? So we will follow the same procedure. Now, there is a stack. First we push the operand 2, 5, 6, 3. Now we come across an operator plus. So what we have to do? We have to place plus here and we have to see 3 plus 6. 3 and 6 is evaluated. 3 plus 6 is 9. Push back to stack. So 9, 5, 2 are the stack contents. Now what we get? 5. 5 is pushed. Then again star. Since star is there, 5 star 9. 5 and 9 are called. What is 9 5 to 45? So 45, 5, 2 remains in the stack. After that, what we come across? Star. Now 45 into 5 is what? 5 4 225. Okay. So 225 is, pushed into the stack. 225 and 2. Okay. 225 and 2. Mistakes. No, right? 225 and plus. We did do the plus, right? Did we do the plus? Yeah, we did the plus, right? We put 9. After that, 9 5 is a 45. Okay. 45 is put. 45 is put. Okay, then 2. Yes, I got the mistake. I was thinking there is some kind of mistakes. Yeah, we did a mistake here. What we did? 9 5 is a 45. Done. After that, there is 2. What is there? 45 is pushed. 5, 2. Okay. Star has been evaluated, then 2 comes. 2 comes. Then again star comes. So when star comes, we have to 2 into 45, which is 90. So this star is being evaluated and put. So 90, 5, 2. This is how it is. Yeah. Then divide. Divide when it comes 90 divided by 5 we have to do. 95 is a what? Sorry, 90 divided by 5 is what? 18. Okay. So 18 is pushed into stack. So 18 is pushed into stack. 19, 5, 18 and 2. 18 and 2 means after that we have to evaluate minus. So minus is what? 18 minus 2. So what is left? 16. So 16 is the answer. So what is the answer of this expression? 16. Okay, this is how we evaluate. I just go through this once again. We evaluate from left to right. 2, 5, 3, 6 are pushed. After that we encounter plus. So 3 plus 6, that is 9, is pushed. After 9 is pushed, the stack content is 9, 5, 2. After 9, 5, 2, what happens? Then again we get 5. Then we push 5. After that we push 5. Then star. When star comes, we have to evaluate 9 into 5. 9 into 5 is 4 and 45 is pushed. After 45, then we again get 2. So 2 is pushed. After 2 again we get star. So we do 45 into 2, 90. Then we push 90. 90 is pushed. After that divide comes. So 90 divided by 5 is done. 90 divided by 5 is 18. So 18 and 2 remains. After that minus comes. So when minus comes, 18 minus 2 is evaluated, which results in 16, and 16 is pushed back into the stack. After that there is nothing. So 16 remains in the stack, which is the final answer. Okay. So I hope you got it. This is how we do the postfix and prefix evaluation. Okay. This is how a computer evaluates using postfix and prefix expressions. So I think stack has been fully covered now. All you have to do is start, doing programs. Try to, do practice code programs using stack. Suppose, take it as a homework. The question is to, using stack, push 5 elements into the stack and print the first 4 elements, add all the elements and print the result as an answer. The output is the addition of the stack element. Can you do it? Try doing it. Okay. Push 5 elements into the stack, add those 5 elements and result output or print the addition of those elements. Okay, this is the homework for you. Try practicing using stack. Okay, try to define a stack and write the code for pushing 4 elements, write a function for push and call that function 4 times so that you will push 4 elements. After that access to the element and calculate the sum and then print the sum. Okay, this is what the logic is, and you implement the actual code. Okay, now we will start with just the introductory part of queues. Sorry about that. Queues. So like star, queue is particular property. It works in FIFO manner. FIFO means first in, first out. Unlike stack, which works as a LIFO manner, last in, first out. Okay, whatever element we pushed into the stack, the last, that only we can access at first. Without accessing that, we cannot access the inner element. That was about stack. In queues, what happens is, whoever comes first, that thing has to be accessed at first only. First in, first out. So you can imagine it like a queue. Suppose you want to book a ticket in a railway station. What do? You maintain a queue, right? Whoever comes first is served first. That person is addressed first. If someone comes in line, then the next person will be served. Then the next person will be served. The queue grows, and as and when people come, that way only they are addressed. Their issue is addressed. So this is suppose person 1, this is person 2, person 3, person 4, person 5, person 6. So one is front end and then another one is back end. Okay, there is a front end, there is a back. So the back is called rear. The back is called rear. One end is front and one end is rear. Addition of all elements always takes place from the rear end. Addition always takes place from the rear end. Deletion always takes place from front end. Deletion always takes place from front end. We can delete element from the front and we can update the front end. Now, after deleting this 4 element, what is front? Front is 5, isn't it? This is front. This is how a queue is updated. Now, suppose after 6 I add 7. Addition takes place from rear end, as I said. 7 is added, so rear is now what? This is rear. This is not rear anymore. Rear is pointing to 7. Front is pointing to 5. So, this is more or less how a queue works. So, we will more formally define what a queue is in terms of code, and we will see what are its components. Like we have 2 pointers called rear and front, and it also maintains a what? An array to store the elements. Okay, what are the? There is a predefined size of a queue. Okay, so in such cases we will see how a normal queue works and what are the problems with normal queue. Then we will switch back to circular queue. There are also circular queue that we will study later. Okay, so I think today we have discussed enough, and if you have any doubt you can post it in the comment section or you can contact me through WhatsApp.